Okay, so we're gonna set aside the lumber pricing and board feet stuff. We're gonna get back into our regular measurement conversions for a while. In the next couple of hours, we are gonna finish up Unit 2, which means for you guys that Wednesday is going to be your Unit 2 unit test. So just a warning of that, so that you know that it's coming up. Also, you guys probably got in the email, you probably got a notice saying that course evaluations are available for you to do electronically. On Wednesday, we're going to do course evaluations. You guys get to do them as a group, so they'll take you next door into the computer lab and you can do the course evaluations.
I love this class. It's the best
So
class I've had.
you'll probably get out of about 20 minutes, 25 minutes or so of class to do the course evaluations. I've been selected this year to get the focus groups done, so you guys will have someone come in and talk to you guys for about 15 or 20 minutes or so too. So you'll have fun with that.
That is taking valuable time from my education.
It'll pay off in the end because that way I get feedback so I know what to change to make it work better for you guys.
Remember those first couple of weeks where you picked around just as much as we picked around?
So anyway, we have a couple of things to get through today, and like I said, tomorrow we'll be finishing up Unit 2, so Wednesday will be our Unit 2 test. So we're going to be looking at measurements of capacity to start out with. Now we've done volumes. And the difference between capacity and volume is a volume is derived from length measurement. It is three length measurements combined to create the size of something. Capacity is just a standard size. Now the unit we usually start with for capacity is a gallon. And a gallon was typically what was held in a man's hat. Most hats, now you're not talking your baseball caps, you're talking about the real hats, like the derby hat, stuff like that, would typically hold about a gallon. Lincoln's hat was a little bit bigger. That's a stovepipe hat. That's a little bit bigger. Smaller than a gallon, what do we have? A quart. How many quarts are in a gallon?
4.
4, yeah. And the easy way to remember that is the word quart actually comes from the word quarter. There are 4 quarters or 4 quarts in a gallon. Smaller than a quart, we have a pint. A pint was actually a standard size cup for serving, usually for serving ale, not beer, but ale. Smaller, a beer mug is slightly bigger than an ale mug. A pint, how many pints in a quart? 2 pints in a quart. Now, a little note here, pints and quarts, the abbreviation. QT for quarts, PT for pints. Depending on the type font, a Q and a P are a lot of times the same letter, just flipped over, so be careful with them. I see that mixed up a lot. Smaller than a pint, we have a cup. How many cups are in a pint? 2, yeah. A cup is sometimes referred to as a half pint. Smaller than a cup, we do have 8 fluid ounces in 1 cup. Now the other ones that you just mentioned, the tablespoon, are in there. 1 fluid ounce is 2 tablespoons. Or 1 cup is 16 tablespoons if you want to do it that way. Now, tablespoon, the abbreviation can be TBSP, like I just did, or it can be just, sometimes it's done with just a capital T. Now, of course, the next one smaller is tablespoons. That's sometimes done with just a small t, so you gotta be very careful. Teaspoons is sometimes TSP. Tablespoons is sometimes capital TSP. I always do it with a capital T because it generally is capitalized, but I do TBSP, so you know it's tablespoon. But it can sometimes just TBP. Sometimes just a TSP with a capital T instead of a small t. So you've got to be very careful. The abbreviations for tablespoon and teaspoon are sometimes confusing. And you do have to, by the way, there are 3 teaspoons in a tablespoon. And you do have to be careful. If you have a recipe, let's say it calls for 4 tablespoons of sugar, and you put in 4 teaspoons of sugar, it doesn't taste right. Or even worse, and this one happened to me once, chocolate chip cookie dough. asked for 3 teaspoons of salt. Now we accidentally put in 3 tablespoons of salt. I could not. I mean, I have not thrown away too many cookies in my life, but I could not choke those down. Those were done for. Now the next few you don't have to write down. I'm just going to throw these out there so that you know they exist. A teaspoon consists of 2 dashes. A dash, you know, they have the big, like a salt shaker. Well, the spice shakers they used were a little bit bigger back then. They had a little bigger holes, but it was just literally take 1 dash of the shaker was a dash. 2 of those made a teaspoon. Smaller than a dash, there was a pinch. 3 pinches and a dash. And smaller than a pinch, there were 2 smidgens in a pinch. Now the pinch was those are actually real units. I have a friend of mine who's a caterer. She actually has the measuring spoons for these units. The pinch was literally just you reached in with your fingers and that was it. Pinched it together. A smidgen, I think, is kind of nasty. You just stuck your finger in whatever stuck to your finger. You flicked it in. So yeah, if you got really sweaty fingers, you got big smidgens. That's nasty. The cup was actually just from your cupped hand like this. My friend, the caterer, I've tested her. She never uses a measuring cup for cups. She just dumps the flour or sugar in her hand and drops it in. She's dead on every time I've checked her. So,
You can see him just lugging like a whole bunch of cute rolling around.
I'm gonna check your cup. There are units bigger than a gallon, like a barrel. Anybody know how many gallons are in a barrel?
Yeah.
55 is actually a drum. 55 gallons is a drum. 31.5 gallons. A quarter barrel is 7 7/8. Yeah, that's a barrel of oil as well. It's 31 and a half. Actually, I think for a barrel of oil, they call it like 126 quarts or something like that for oil, which is the same thing. But
How much is a keg?
how much is a keg?
Yeah.
Keg is a barrel.
Can we just put that in there?
How about a bushel?
Oh boy.
You got a bushel of corn, a bushel of fruit. A bushel is 8 gallons. How about a peck? If you ever gone to an orchard to buy apples, you got the peck bag, the half peck bag. Or if you go to pick strawberries, you got the 2-peck tray you buy. There's 2 gallons. You ever hear the old tongue twister? Peter Piper picked a peck of pickled peppers.
Yeah, but I can never say it, so I never understood the word of that.
Sure. Well, that's how many pickled peppers he picked. It was a peck. 2 gallons. Now, there is a relationship. Obviously, volume and capacity are measuring very similar things. There is a relationship. 1 gallon does contain approximately, so I should do this instead of the equal sign, approximately 231 cubic inches. Now, 1 cubic foot is larger than a gallon. Here's the question that always stumps me. A 5-gallon bucket. I think we talked about this before. Your 5-gallon bucket, I think that's more or less than a cubic foot. 5-gallon bucket, it seems like it should be more than a cubic foot. It's more than a foot tall. It's almost a foot around. It's actually quite a bit less. 1 cubic foot is actually 7.48 gallons. So a 5-gallon bucket's only about 2/3 of a cubic foot.
1.4?
What's that?
1.48 gallons?
1.48 gallons.
So that's a 5-gallon thing.
Wow. Yeah, okay. She's 7.48 gallons in a cubic foot. Did I actually do that? I'm sorry.
Wow.
I said 7.48 the first time, didn't I? Okay. It's a Monday. The little hamster has not found its way to the wheel yet for the week. Okay. So those are our units, standard units of capacity. And like I said, we've got that conversion between volume and capacity. So if let's say you guys have a tank. I've actually done this calculation quite a few times. Even this summer, I did it 4 or 5 times for people. We're going to keep it simple. We're going to go with a square tank for right now, or for a rectangular tank for right now. But let's say that this one is, what's that?
Don't make this hard.
Don't make it hard? Okay, we'll make it simple for you. Let's say it's a pool. It's 4 feet deep, 20 feet long, and 12 feet wide. How many gallons of water does it hold? I'm going to give you guys a minute to see what you come up with. So you got 960 cubic feet times 7.48 gallons per cubic foot gives us what?
Wait, where did you get 7.4?
That's how many gallons are in a cubic foot. So 71,000 from right here. Okay. So yeah, just under 7,200 gallons in that pool.
Wait a minute.
So let's say we have a pool that is 80 inches diameter by 30 inches tall. Find the number of gallons in that one. So first we got to find the area of the circle on the circular base. That's going to be pi times 40 squared, right? So what is that? 502. Is it 50,240?
No, 5,020.
5,024. 26. 26 if you use the pi key. Okay. We'll go with your numbers. We'll go 26. I was using 3.14. And then, of course, times the 30 inches gives us what? 780? 150,780? That is in cubic inches. Now, if we go to gallons, we divide by 26 times 3, 78. I was using 5,026, no decimal.
My calculator says 150,796.
You used something. You used 36 instead of 26 or something.
Oh, maybe because I used 5.
That would work. So 150,780 divided by 231 cubic inches per gallon gives us 653 gallons, about 652.7. 231 cubic inches in a gallon. So yeah, that doesn't look that, I mean, 80 inches and 30 feet deep, that does not look, or 30 inches deep, that doesn't look like a very big tank. That's 653 gallons. Significant. I did that calculation a lot this summer for people with their swimming pools, figuring out how much chemicals to put in. And yeah, most of your average swimming pools, even like the 16 or 15 footers that are 4 foot deep that you buy at Walmart, most of those still hold between 4,000 and 5,000 gallons. It's a lot of water. And if you're looking at 12 cents a gallon, you got 5,000 gallons, you're looking at, what, $60 of water just to fill the thing?
That's why you only fill it
How
once.
many gallons are in Lake Superior?
That'd be a tough calculation. There's a lot. There's billions of gallons in Lake Superior.
How do they know?
I think we should do it right now.
We need some math.
Tell you what, you guys look up the square mileage of Lake Superior, and Tuesday or Wednesday we will do that calculation. Last day. So now we're going to talk about weight and mass. We talk about them together because they tend to be used interchangeably, even though they are quite different. Weight is a measurement of the force of gravity on an object. You only have weight because you're on Earth and the Earth has gravity. If you were floating off somewhere where there was no gravity, you would have zero weight. That's how astronauts are capable of achieving what they call weightlessness. It's actually not weightlessness, it's just very, very minimal weight. Because they're in a spot where the force of gravity between the planets and the Earth and everything else balances out. So they have zero net gravity on them, zero net weight. Again, it's not zero weight, it's actually, there's a slight weight, it's just not enough that you see much of an effect. But anyway, mass is the amount of matter in an object. Matter is like the particles, the atoms and stuff like that inside the object. The big difference, weight is usually measured against a spring. Just hang with me. So you put the object on the end of the spring, it stretches it out, and the string stretches, and there's usually an indicator on it. And where it ends up, that's the weight, and there's a numbered scale here like a ruler. Wherever that indicator ends up, that's the weight of the object. Mass is measured using a balance. You put your object on one end of the balance. Displacing volume doesn't work because things have different density. So the same volume could have different mass. There's still more material packed into it. But you put a known mass on the other end of the balance, and whatever balance is, that is the mass of our unknown object. You'll notice mass is not dependent on gravity. If we go to the moon where gravity is 1/6 of approximately that on Earth, sure, the polar gravity on our object changes, but also the polar gravity on our known mass changes, and it will still balance. It has the same mass. But if we take our scale to the moon, the spring is going to stretch less, and it'll have much less weight because there's less gravity. Now on Earth, gravity is relatively uniform no matter where you go. There's actually slightly less, the force of gravity is actually slightly less at the equator than it is at the North and South poles. There is a slight difference depending on where you are on the Earth. Very, very slight. But it's so close to the same everywhere that they tend to use mass and weight interchangeably. So if you know somebody's mass, you can figure out their weight and the other way around. So they tend to kind of put them together. Now the main reason why I bring that up is in the standard system, we tend to actually use units of weight. So let's go through the standard weight. So in the standard system for weight, let's start out with the big one, the ton. How big is a ton? 2,000 pounds. 99.999% of the time, when you hear the word ton, they're talking about 2,000 pounds. That is actually what is called a net or a short ton. Like I said, almost all the time. Every time in this class you hear the word ton, we'll be talking about 2,000 pounds. If I put a ton on the test, it'll be 2,000 pounds. But if there's a net or a short ton, that implies that there is a gross or a long ton. Right. A long ton is 2,240 pounds. The reason there was a long ton was tons was originally used for measuring grain. And you can't just put a ton of grain on a scale, it runs off. So you had to have it in a container. So the container that held a ton of grain was about 240 pounds. So it's kind of like your paycheck. Your gross pay, you work 40 hours, you get 10 bucks an hour, that's 400 bucks. But you don't get 400 bucks. You get a net pay that's much lower. Same here. The gross ton was the grain and its container. The net ton was just the grain itself. The container was 240 pounds. Yes. Like I said, in this course, whenever you hear the word ton, you're going to think 2,000 pounds. Smaller than a pound. By the way, the abbreviation for pound is LB. It would make sense to use PD for pound. But in the bookkeeping for buying and selling grain, PD was already used as the abbreviation for paid. So you didn't want to confuse those two. So they used LB, which was from the Latin word libra, which is the Latin word for pound. 1 pound is, what's the next smallest unit? Ounces. There's 16 ounces. Now, just a side note, by the way, in the English language, if enough people tend to screw something up, often enough over long enough period of time, it becomes acceptable. Because enough people have made that mistake, PD is now an acceptable alternative abbreviation to pound. I'm not going to use it in here, LB, or sometimes just the hashtag sign for pound. I don't like PD. It's sloppy. But like I said, enough people have made that mistake that it's now become an acceptable alternative abbreviation. It's one of the funny things about the English language. For example, can any of you want to spell potato for me? Yeah, P-O-T-A-T-O is how you would spell it. 50 years ago, that would have been incorrect. Toe has T-O-E on the end. There's an E on the end. Is the technical spelling of potato. But enough people forgot the E that somewhere in the 60s or 70s, with dropping the E became an acceptable alternative spelling.
Go figure.
Now, I mean, not that it matters, but it's just kind of funny that the English language like that. Enough people do the same thing over and over again, it becomes acceptable. What's that? No, it's just it's considered an adaptive language is all. Smaller, by the way, the abbreviation for ounce is OZ, which also comes from the Latin word for ounce, which I can't remember right now, so it's OZ. There's something smaller than an ounce. There is a dram. 1 ounce contains 16 drams. The dram before the metric system was the original apothecary unit. You might get prescribed 1/8 of a dram of a medication or 1/4 of a dram of medication. There was also, for those of you that are hunters, you might know this one, 7,000 grains in 1 pound. Gunpowder, of course, for your bullets is measured out in grains. A grain was literally like a grain of salt or sugar. I don't remember which it was now. It was one of those two. And it was a volume. 7,000 grains in a pound, or not a volume, it was a weight. You measure it out, and grains was also used for measuring medication. And it was so ingrained in the medical field that when the medical field switched to metric, they actually have adapted. Grains have been absorbed into the metric system now as well. Now you hear a lot on the news about precious metals. You might hear gold reached $1,800 an ounce. You're not going to be tested on this. I'm just throwing this out there for now so you're aware of it. Precious metals are not measured in the pounds and the ounces that we're used to. I mentioned it before when we talked about the meter and how it would have been really nice if the meter would have been the same length as the yard. But the fact that the yard standard measurements are not standard, whatever ruler decided to declare his arm was going to be the official yard, well, we said the meter was actually equivalent to the Swiss yard. Well, the same thing happened to pounds and ounces and stuff like that as well. What they used in one area for the standard pound was different in another area. So, precious metals, the headquarters of the world for buying and selling precious metals was in the Mediterranean Sea on the island of Troy, just off the coast of Greece. So when we buy and sell precious metals, they are still bought and sold using Troy measure. 1 Troy pound is only about 0.82 regular pounds, US pounds. One Troy pound only contains 12 Troy ounces. So a Troy pound is slightly smaller than the US pound, but the Troy ounce is actually slightly larger because there's fewer of them in a Troy pound. Now again, you're never going to be tested on that, but you hear a lot about invest in gold and buy silver and all that stuff. Just so you know, those are bought and sold in different units. Now, 1 fluid ounce was originally defined to be the weight of 1 ounce, or the size of 1 ounce of water. But these units have all been adjusted through the years, so it is not quite exact anymore. A gallon of water should be 8 pounds. It's actually a little bit different than 8 pounds, but it's really close. Now, in the metric system, if we look at capacity, there's only 1 unit of capacity, and that is the liter. Just like units of length, we only had the meter. Get used to seeing liter spelled litre. That's the European spelling. It is catching on. Meter, the European spelling is TRE as well, but that doesn't seem to be catching on in the United States quite as much. That's the European spelling. That's just how they spell it. Don't know why. The U.S. spelling is still liter. Now, I was always told when I was young that the proper abbreviation for liter was a capital L, not a small l. The reason for that is in some of your older type fonts, an L and a small L and a 1 are indistinguishable. So let's say we had this. Is that 5 liters or is that 51? Well, it's a capital L. It's pretty obvious that it's 5 liters.
Well,
Now with your modern type, what's that?
When you always put a period after the end.
No, you don't. Not in the metric units. You don't put a period when you abbreviate them. For some reason, I couldn't tell you why that is. But anyway, now with your modern type fonts, most fonts you can distinguish between a 1 and a small l, so it is okay now to use a small l to abbreviate liter. For mass, notice I said mass, not weight. In the metric system, they tend to focus on mass. By the way, in the standard system, there is a unit of mass. Anybody know what it is? Standard mass is a slug. 1 slug is 32 pounds. No, it's a pretty big slug. Most people have never even heard of that unit. This doesn't get used very much. In the metric system, we tend to focus on mass instead of weight. Mass is measured in grams, abbreviated with a small g. There is weight in the metric system. We're not going to use it. It very seldom gets used outside of science and engineering and design. In the metric system, weight is measured in newtons. 1 kilogram is about 9.8 newtons in weight. So I'm going to put our conversion chart. I'm going to put both liters and grams in here because it's the same chart. So we have deciliters and decigrams, which are 1/10 of a liter or 1/10 of a gram. Centiliters and centigrams, again 100. Milliliters and milligrams, again 1,000. And then we skip down to micro. Liters are micrograms, which is a millionth. Going the other direction, we have decaliters or decagrams, which is 10. Hectoliters and hectograms, which is 100. Kiloliters and kilograms, which is 1,000. And then we skip up to mega, which is a million. So megaliters, megagrams. Megaliter is almost never used. A megaliter is like 270 some gallons. So we tend not to use the megaliter. Or, kiloliter is 270 some gallons. A megaliter is just way huge. 270,000 gallons. It just doesn't, it's not practical. A liter, and we'll talk a little bit more about the standard to metric conversions tomorrow if we need to. 1 gallon is about 3.785 liters. So a gallon is 4 quarts, so a liter is bigger than a quart because it only takes 3.785 liters. 1 kilogram is about 2.2 pounds. It's actually like 2.208 or something like that, but we just use 2.2 usually for the conversion. And the converting of units in the metric system is the same as always, same as with length. If I give you 0.37 liters and I want to know what that is in milliliters, what do I have to do? Yeah, 1, 2, 3 spots to the right. Decimal goes 1, 2, 3, add a 0. That is 370 milliliters. Or if I tell you that something is 820 grams, how many kilograms is that? Yeah, so from gram scale is 1, 2, 3, so 1, 2, 3, 0.82 kilograms. Now, one of the really nice things about the metric system, we talked about this before, that the metric system was planned. 1 milliliter is defined to be 1 centimeter by 1 centimeter by 1 centimeter. So 1 milliliter is 1 cubic centimeter. 1 gram is defined to be the mass of 1 milliliter of water. So all of the units, length, capacity, and mass, are linked together in the metric system. It's kind of nice. For example, let's say, first of all, let's look at a car engine. Let's say I've got a car engine. Let's say it has a 7 centimeter stroke to it. And let's give this a 10 centimeter bore. This is a 6-cylinder. So the volume, let's see, if the area of that piston is going to be pi times 5 squared, right? Or 78.5 centimeters squared. Times the volume, so times the 7 centimeters. Gives the volume in that cylinder of 549.5 cubic centimeters. Now, of course, there are 6 cylinders, so times 6. 3,297 cubic centimeters. Now, of course, to convert that into milliliters, how many milliliters is that? 3,297, because 1 cubic centimeter is a milliliter. And then to liters, yeah, 3.297, probably 3.3 liters is what they'd round that to. That's a 3.3 liter motor. Ford? Well, it's not like I actually, you know, Ford was big on the 3.0.
I know Honda had a 3.2 V6.
Yeah, Honda had a 3.2. Ford was big on their 3.0, and I don't know, they went to a 3.4. Let's see.
So then how do you calculate horsepower?
Horsepower can go off of displacement, but there's other factors that go into it as well. Horsepower is usually done at the wheel rather than at the engine, at the crank. Horsepower can be calculated at the crank, at the flywheel, or at the wheel. And it's much different either way. Actually, most engines are calculated on a dyno, which means the engine is pulled out of the car and it's at the flywheel.
Sure, you know.
And it's just done under resistance is all it's done.
I don't know, I think they're kind of leaning away from that though, to get to lower horsepower.
It's possible. They're putting it right at the drive wheel instead of the flywheel. So you can see that is one really nice thing about the metric system is all those units are linked together. For example, let's say I give a jug. For cars we do, but we don't for most standard stuff. It's still gallons and quarts. Except for like a lot of your milk hasn't switched yet, but like most of your pop and stuff like that is, yeah.
Why is milk still in gallons?
Just hasn't switched over yet. Why do you still buy gas in gallons?
That's the way you're supposed to do. Because we buy oil in gallons.
Tell me, if this is water, this is full of water, what is the mass of the water that would fill that up? Well, this is a radius of 10 centimeters, right? So the area of the base is pi times 10 squared, which is about 314, correct? So that gives us a volume then of 314 times 30 centimeters of height, which is what, about 9,420 cubic centimeters, correct? Which is about 9,420 milliliters, correct? because a cubic centimeter, and a milliliter are the same unit, which is about 9,420 grams of water, correct? Because a milliliter of water is 1 gram. So if that's grams, it's 9.42 kilograms. Just move the decimal 3 spots. For those of you that want to know, 9.42 kilograms, 1 kilogram is 2.2 pounds. It's 20.7 pounds. So it holds about 20 pounds of water. What do you think? Good stuff?
No.
You'll learn to enjoy it. You need to go back? Need to go back up here for a second? Or you got it? Okay. In the big book, there's going to be a few pages involved here. On page 253, it's exercise 8-9. Page 254 is exercise 8-10. Page 255, it is exercise 8-11. Page 256, exercise 8-12. Page 274, exercise 9-11. Page 274 through 275, exercise 9-12. Page 275. Do you want me to sign the whole book? 9-13. Let's do tomorrow. And page 276, exercise 9-14. It looks like a lot, but it goes really quick. It's just the standard and metric capacities and masses and weights. Just do the odds. See, I just cut the assignment in half for you.
It's usually a really good indication.
You guys are wimps. You guys all got the pages down?